Hi everyone, my name is Tim. I'm really honored to be here today just to chat a little bit about some of the things that I've come across. So really, I hope to just share three things with you today. How databases think better with AI, how databases predict better with AI, and how databases personalize better with AI. Okay? So, well, first, I guess we need to kind of call the elephant in the room. Oftentimes, we say AI, which is short form for artificial intelligence, and we're not really sure about what that really is. Like, we hear it all the time in your social feeds, in the news. But what really is artificial intelligence? So maybe we'll do a quick history lesson on artificial intelligence, because it's really not that long of a history, sort of back in the 1940s. So I'll take us along a bit of a pathway or a roadmap of where artificial intelligence, where AI has been. But just so you know, I also asked ChatGPT if it could let us know what were some of the culturally significant moments of each of these different areas that AI has shown up in our history. So 1940s to 1950s is when we first started hearing the term artificial intelligence. In research, there was a lot of curiosity about, well, is it possible that one day machines could do the things that humans can do? And that's also where the Turing test came about. A researcher by the name of Alan Turing decided to do a test. So you would have a human judge interacting with a computer and another human. If the computer could convince the human judge in a blind test that its response was coming from a human, it would have passed the Turing test. Okay? And even to this day, they still refer to the Turing test. You'll hear that often as one of the benchmarks whenever any of these new AI tools come out. So that's kind of where it came from. Now, ChatGPT would say that in the 50s, a cultural moment was rock and roll music. So the likes of Elvis Presley, Chuck Berry, Little Richard, all prolific musicians of that time made an impact on the culture of North American history. So we move on to 1960s to 1980s. They call that the AI winter. So as it usually happens, whenever there is new technology that comes out, there's lots of excitement and a lot of investment that goes into understanding how this technology might be disruptive. But then, if nothing happens, then you get a lot of that funding drying up. And this is exactly what happened in the 60s to the 80s, where a lot of the initial funding and excitement around artificial intelligence just started to peter off. Well, thankfully, according to ChatGPT, that's also when in 1977, Star Wars: A New Hope was released, which forever changed the way that Hollywood movies were produced and released. Okay, let's move on to the 1990s to the 2010s. Hadn't heard much about artificial intelligence, but then all of a sudden we started hearing that AI was beating humans at the games of chess and at Jeopardy, two activities that were always thought to be very sacred to humans, that they could only be the ones that were excellent in. Okay? Well, 2007, that's when the first iPhone came out. And this forever changed the way that you could, in a very small form factor, carry a lot of information, the way that humans would start communicating with one another. So ChatGPT thought this was a culturally significant moment in our history. Okay, so let's move on to 2014, 2020. This is when we start hearing about neural networks or general pre-trained transformers, GPT. So have you ever thought about what the GPT and ChatGPT stood for? Okay, well, you're welcome. It was also at this time that platforms like TikTok started to become very popular, and now forever changed the way that humans could record themselves dancing and be watched from all over the world. Okay, 2020 to 2024. So in November 2022, it might be one of those questions. Where were you when you first heard of ChatGPT? Well, that was when OpenAI released ChatGPT 3.5, and now all of a sudden generative AI has become mainstream. ChatGPT, incidentally, would tell you that it's also in the same period that Taylor Swift and her Eras Tour created a very significant cultural moment for the human species, just in the way that popularity could grow, the way that fans could engage their idols. And that takes us to March. So this is where we are now. Okay, so artificial intelligence, AI, really hasn't been around for that long. And yet we can see just in the course of a few decades just how much it has evolved and grown. So if we were to think of artificial intelligence and some of the other terms that we keep hearing about, like where does ChatGPT fit into all of this artificial intelligence? Is ChatGPT artificial intelligence? Well, we start with kind of the biggest view, which is artificial intelligence is really kind of this idea of how can we have machines mimic human behavior? Okay, so anything that kind of falls into that bucket would be artificial intelligence. We hear about machine learning being a subset of artificial intelligence. And this is now where it's about detecting patterns, pattern recognition. So it's using ideas from mathematics and statistics to do this pattern recognition. So that's what machine learning is. And then you might hear of terms of, well, you can do supervised machine learning or unsupervised machine learning. But just keep in mind that machine learning is a subset of artificial intelligence. And then contained within machine learning is this idea of deep learning. Okay, so deep learning now is where we start going into these ideas of neural networks. So taking these tools and almost like mimicking what the human brain does is a way that deep learning does. It still is fairly technical in terms of pattern recognition, but now it's dealing with a lot of data and a lot of complex logic. Okay? And so buried within deep learning is where we find generative AI. So generative AI is essentially a form of deep learning. This is now where this particular type of deep learning is good at creating content. And that could be text, could be audio, it could be video, could be code. So a lot of the tools that we've been hearing about in the last couple of years, so whether it's your ChatGPT, your Geminis, or whether it is tools that can create synthetic voice or video, that's all in this generative AI bucket, which again is a subset of deep learning, which is a subset of machine learning, which is all part of artificial intelligence. Okay, so you've studied database. I've just pulled a few slides from a first-year business course that gets taught at U of C. So you've probably come across ideas of a database management system. You've heard about things like why a database is important, because it helps to remove things like data redundancy or data isolation. So just a way to be able to make sure that your data is in a way that you can get to it and be able to use it in a valuable way. You've heard that maybe databases will help with the security of the data, ensuring its integrity. So I'm hoping that a lot of these topics are familiar to you, that through the last couple of months you've covered some of these, where you're talking about database management systems. You've maybe encountered data tools like Microsoft Access or Power BI, pivot tables, I think I saw in your course outline. Particular coding or querying languages, so SQL, QBE, these are some very commonly used ways that those that are working within databases will try to extract and model the data that is at their disposal. Because at the end of the day, you want to make sure that that data is producing something that's valuable for you. Okay, because if you don't, this is what could happen. Okay, so back in 2023, Toyota, the car manufacturer, experienced a 36-hour outage. But this happened at 14 of their plants. Okay? This was a $1.5 billion issue. Okay? So just in a matter of less than 2 days, just by not having your operations available, it can be very costly. So what happened here? Well, there ended up being they did some root cause analysis afterwards and discovered that there was a database capacity planning issue. Okay, so what does that mean? Well, they kind of ran out of storage, okay? You might get those annoying messages from Google from time to time that say, hey, you're at, 88% of all of your storage. If you want to, you can upgrade. I think Apple does the same thing as well too. Okay, so imagine that on a much more grander scale that has a much more significant impact on a company's operations. Toyota, is very famous for their lean or their just-in-time approach. Okay, so they're type of organization. They don't keep a lot of inventory on hand, and so everything needs to be a well-oiled machine in order for their company to be successful. And so you will also know that a relational database is more than just a collection of rows and columns or connected tables. It will also store temporary files. It will store indexes that are used for rapid access, log files, backup files. So you can now see how when you have that much data and you're creating that much redundancy, all of a sudden, if you're not careful, you could run out of space. And that's exactly what happened to Toyota. Not only that, but because of how integrated Toyota is with all of its suppliers, it's not only their database, it's all of the other databases that are all working together. And so because of the failure of capacity planning, all of a sudden, they ran out of space. And then the database was not working anymore. And so it resulted in 14 plants having to shut down for 36 hours. So I think you get the importance of having good data and having good data systems. Because if not, this is what could happen. Okay, so databases have always been kind of managed in a certain way. This is what we'll call the traditional approach to database management. But we are entering an age of AI. If you remember, we're kind of past the Taylor Swift part of the roadmap. Well, this is kind of like the AI age, right? So how does that affect the way that data gets managed? How does that maybe optimize and improve database management systems? Okay, well, the reason that we need to start moving away from the traditional approach to a more AI-empowered approach is the growth of data. So nowadays, there's so much data. Like organizations aren't only just generating data for reporting, but they could be gathering data every 5 minutes or every 5 seconds. So just the amount of data that is now being gathered has grown exponentially. On top of that, the data is much more complex. It's no longer just zeros and ones or formulas. Now, an organization's data could include text messages, audio podcasts, YouTube Shorts, TikToks, Instagram Reels. All of that is data. But it's much more unstructured than, say, your typical conventional data would be. So a combination of just the growth of volume of data plus the complexity of the data is now forcing a different way and approach of how it is that you will manage your data. If you can do it, lots of benefits that you can grasp at. Okay? Database performance increases, you reduce the administrative overhead, which then translates to cost savings. You can scale your organization better. It's really important to make sure that, especially in a very dynamic state that we're in, that your organization is also adaptable to all the changes. So you want to make sure that your database system is also just as adaptable. So at the end of the day, this will just help businesses, actually it helps organizations to make better decisions and to make them faster. Okay, so this is why it is that there has to be a transformation of the way that databases are being managed. Oh, you may have noticed the video at the beginning. And here, I'll always let you know whenever something's AI generated. So the workflow here is I had Midjourney create an image. I just said, hey, I don't know, database management. I didn't give it a lot of clues, and it created some images for me. Then I took that and put it into a different tool, which takes static images and converts it into a moving video, like what you see there. And then finally, I bring it into a video editor just to kind of clean it up a bit. So Vincent was just talking about how I have this penchant of wanting to bring some AI stuff into the classroom. And part of that, it gives me the chance to then try out some of these tools. Because I do find that there's a lot out there, and it can be daunting. But if you just, 5 minutes a day, just try to do something using one of these AI tools, you'll become more comfortable with it. And who knows, where in your life that this might show up. Okay? So AI can absolutely enhance the way that databases are being managed right now. And I'll just highlight 3, but there's many more than just 3. In the way of data tuning, anomaly detection, and then predictive maintenance. Okay? So these are all things that would have been done already from a database management perspective, but now they can be further enhanced by using AI approaches. Okay, so data tuning is really this idea that you just want to make sure that your database is optimal. You may have already talked about first normal form, second normal form. So this whole idea of normalizing your data is a way of fine-tuning it, because you probably know how hard it is to use just a spreadsheet with a whole bunch of rows and a whole bunch of columns, and you're trying to find something very specific to answer a question. So then you apply your normalization techniques to try to get to it, where you remove duplicates, you put them into kind of logical groupings. So this keeps on going on as a means of fine-tuning and optimizing your database. Okay, well, what if you could do that without or with very little human intervention? Okay, well, this is what AI is starting to do for databases, particularly for data tuning. So not only does it do some of the tuning, but you'll know that the cleaner, the more structured your data is, the more secure that it is. It's less prone to errors because there's maybe two versions of the truth. But now if AI can do that for you, it significantly increases the security of your database. Okay? It can automatically create indexes. It can automatically adjust memory. So sometimes you may, if you're a gamer, you'll know this, right? Sometimes your computer will kind of dial up or dial down depending on how intense the rendering of the graphics is. It's always about FPS, isn't it, right? So you want to make sure that you have the highest FPS. Well, your computer is fine-tuned through the orchestration of the various processors to make sure that you, as a gamer, have the best gaming experience, highest FPS. And so similarly, AI can do that for databases as well too, to kind of optimize how the resources are being used and the memory as well too for the database. Okay? So hopefully you can see, just by introducing AI practices into some of this, improve efficiency, reduce latency, and ultimately help to save the organization some costs. Okay, anomaly detection. So this is a very important part of the data practice. Data needs to be trustworthy, and so the sooner that you can detect anomalies, the sooner you can go and fix that so that the data continues to remain trustworthy. So we already talked a little bit about how deep learning, machine learning is all about pattern detection. So AI is really good at that. It's really good at going through a whole bunch of data and being able to tell you, hey, something's off here. Okay? So if you can have machine learning models continuously monitor your relational databases to look for these type of anomalies, well, then it can give you early warning signals to say, okay, there might be something that's happening here in your data that's causing these anomalies to happen. So when you can have early detection, not only is that for just the integrity of your data, but you might actually start to notice certain behaviors that might be causing those anomalies. So fraud detection is a really awesome use case of this type of early warning detection. If you can start to see, I don't know, transactions that may be occurring where they really shouldn't be. Imagine if you were a controller or an internal auditor. Well, this type of superpower enables you to be able to catch a lot of things, bad things, before they become a big issue. Okay, so that's kind of another benefit of using AI in your databases, is this automated anomaly detection. Okay? And like anything else, like our bodies, like our vehicles, like our homes, everything always has this tendency of breaking down, of rotting, of degrading. Right? Same thing happens with database as well too. If you are not caring for it, tending it, and stewarding it, your database can also rot and degrade as well. So maintenance is always a key part of any database administrator's role, just to make sure that the integrity of your data is always maintained. So what AI can do is self-healing. Okay, so if you were a database administrator and you had noticed that there was something that was an anomaly, so something that wasn't quite expected, normally what you'd have to do is you'd have to make a copy of the database, you have to go into a virtual environment, you have to run some tests, you might have to restore it to a recall point where the data was fine before, do your root cause analysis to figure out what had happened, and then finally you can then promote any changes or fixes to your production database. Okay, well, AI can do all of what I just said in the last 20 seconds, like in a snap of a finger. Okay? So this is kind of where you can see some huge savings and efficiencies by using AI when it comes to this part of maintaining your database. Okay? So of course, minimize downtime. the equipment lifespan. So sometimes when a database gets so corrupt, you have no choice but to rebuild it, and then you end up having to start from zero again. But by having this type of self-healing that's in place, okay, well, all of a sudden you are now extending the life of your database. Okay, I have yammered on for a bit. That was talking a little bit about how AI helps databases to think better. Okay, now let's maybe shift gears, looking ahead. How does AI allow databases to predict better? Okay, so now we're looking into maybe some of this deeper technology.
What if solving complex math, engineering, and physics problems took no longer than a nanosecond? It sounds impossible, but that's what a quantum computer does. Quantum computers are faster because they allow you to test out all possible solutions simultaneously, all because they use qubits instead of the binary bits used in classic computers. So where binary is either 0 or 1, qubits can be both 0 and 1. Sounds simple, but it opens up a whole new world. It allows for two principles to occur: superposition and entanglement. Superposition's like having a coin that can spin heads and tails simultaneously, exploring all possibilities. Entanglement's like having several coins that communicate with each other. So, if one coin lands on heads, the others know instantly. This connection lets qubits work together, finding the best path through even the most complex mazes.
So hopefully that helps to kind of round out the definition of that. That, yeah, ultimately is about being able to do more complex work in a much more efficient manner, whether it's because we use less computing resources or less time in order to achieve that. Now, from a database perspective, well, how does this tie into databases? Well, underneath all that is the ability, the necessity to be able to store all of that data so that your quantum computing can access that, okay? So yes, the impact on databases is huge from quantum computing. Okay, who has dabbled into cryptocurrencies? Okay, so can you maybe tell us a little bit about the technology underlying cryptocurrencies called blockchain?
Galen, what's the biggest misconception about blockchain technology?
Candidly, it's a really simple technology. It's just a database. You said it earlier, and people get confused and they start going down the rabbit hole. And unless you're a technologist yourself, think it's super complicated. At a high level, it's not. It's a brilliant idea. It's just a shared database that multiple users can use. I like to analogize it to Google Docs. Most folks use Google Docs. You can group edit a document and see in real time where your colleagues are editing the document. That's what's called a distributed system in computer parlance. Except here's the problem. Google owns your data. A blockchain is just Google Docs without Google owning your data because all of you share it. It's a really simple concept and it's not as complicated. Once you get down into the technology, of course it is, but at a high level, it's just a database. It's just like money itself is just a database entry.
Oh, wow. It's just a database, right? It's been kind of sitting underneath our noses all this time, that this very popular disruptive technology. And cryptocurrency isn't the only application of blockchain. In fact, I'd say probably more common in the corporate side, it's all about smart contracts. So when suppliers and vendors work together, rather than exchanging cash or e-transfers, they can do it using smart contracts based on this same technology. But you probably have all used like group collaboration tools, whether it's on Google, whether it's using SharePoint, but you know what it's like to be able to work on the same document at the same time. So essentially, that's kind of what blockchain is. And so yes, the impact on databases is huge because, I mean, at the end of the day, the entire technology is one big shared database. So the more that you become comfortable with how it is that you can navigate your way around a database, the better equipped that you are to engage in this type of technology. Okay? Here we go. This was the third topic, edge computing. Does anyone know much about edge computing? Has anyone heard of that term before?
Edge computing is revolutionizing the way we handle data, but what is it and why does it matter? Let's break it down. Instead of sending data all the way to a central cloud server, edge computing processes data closer to where it's generated, right at the edge of the network. This means data from your devices, like sensors or smart cameras, can be processed locally on nearby servers or even on the devices themselves. This brings major benefits: faster response times, improved data privacy, and less bandwidth use. Imagine self-driving cars. They need real-time data processing to make split-second decisions. Edge computing makes that possible. From smart cities and IoT devices to healthcare and autonomous vehicles, edge computing is paving the way for a connected, real-time world. Want to know more about tech trends? Follow for more quick insights.
So remember when we were talking about how all this data is now growing exponentially? It's because organizations, they figured out that if they can slap a sensor on everything that they own, they can have a better view of what's happening within their business. So this idea of an edge, just think of everything that you own as part of this network. And the devices that are furthest away are the ones that typically would take the longest to send the data back to you. But by using edge computing, you're now distributing the ability to process all that data, to work with that data right to the edges. Okay, so you might have a refinery that's in Fort McMurray, even though you're headquartered here in Calgary. Well, using edge computing, you put a sensor onto that refinery, and it does all of the data processing there at the refinery, as opposed to having to send all that data up, hitting a satellite, having it come back down to your main data center, and then having you send it back the other way. So edge computing is now distributing all of that right to the edge of your network. Okay? And of course, this will significantly have impact on databases as well, because now you're going to have many different relational databases in order to manage this. Okay, so that was just a quick glimpse of how AI can help databases predict better. So how can AI help databases personalize better? Well, you have probably already experienced this idea of data-driven personalization. So this is the idea that, hey, you know what? The more information that we collect on our customers, we get to know them better. We know what their habits are like. We know what their preferences are like. And then we can make better recommendations, whether it's a product that we have or a service that we have. So, any time that you have ever used Amazon or any other online shopping platform, you are aware of the recommendation engine. And you know that it's based on your purchase history or even how much time that you've spent looking at a particular item. Well, all that information is tracked and gathered and is put into the recommendation algorithm. Same thing happens with any of your entertainment platforms, be it Netflix or be it Spotify. There's always a for you or recommended for you. Okay, that's all examples of their AI-driven recommendation engines. And then, of course, customer service. There probably isn't a website that exists nowadays that you don't go to where there isn't Charlie the bot waiting to interact with you. So this is a very common way that AI has been implemented in a lot of customer service type of applications in the form of a chatbot. Okay, so how do they do it? It sounds like it's, very technical, but it really isn't. A lot of this is just this idea of personalization. In fact, it's hyper-personalization. So if you can figure out all the different features and characteristics of your target customer, whether it's their demographics, whether it's their psychographics, then you can tailor the customer experience exactly to that person. So it's not even just a group of individuals now. It's getting to the point now where they can provide a marketing campaign, a promo code to the right person at the right time, because they know exactly who it is that's interacting with their technology platform. There is this idea of context-aware adaptability. So this is even going beyond just collecting the demographics and psychographics. It is other contextual pieces of information. What is the weather like of the individual that is interacting with you? And by putting all of these other conditions and other features into it, you can even more tailor that experience to the customer. And then predictive behavior models. Okay, so once you have all this data, again, using some of the concepts that you can borrow from machine learning or deep learning, you can start coming up with some predictions and forecasts as to what your customers and your stakeholders might be like. Okay, so I'm certain that Vincent's just dying to come back up here and speak to you, so I'll kind of limit my time. But I think it's important to kind of wrap this up to say, okay, well, so what? You've just heard someone talk for about 40 minutes about databases. I'll be the first to admit that databases aren't exactly the most exciting part of business technology. But I'm hoping that after all this, you do see that, okay, there actually is some important impact that databases can make on society as a whole. So how does this knowledge make you a better future business leader? So I'm going to crowdsource one last time and just kind of put it up to you. So now that you've heard about some of these evolutions in database management, how do you see this helping you in your journey as a business school graduate? Yeah.
I think maybe everything faster, no?
Faster, yes?
Knowledge faster.
Okay. And what they always say is today's going to be the worst day ever that you will see today's technology, because it only gets better from this point onwards. So if you think that technology is already fast, can you imagine how fast it's going to be tomorrow or next week or next year? So that's a great observation just about kind of this awareness that, okay, things are happening fast, but if you're good at databases, you're able to now gather all the information to help you decipher all the speed of information. Okay, so the difference between a database and storing data in a file like Excel, right? That was actually one of the questions that someone put. What's the difference between like a database and Excel? And how relevant is that in the workplace? At the end of the day, you just need a tool to be able to manage your data. So your data could just be email messages. That's data, okay? Your data might be a financial report because it's quarter end. That's also data as well. So whatever works best for you to allow you to store the information in a way that then allows you to retrieve it later on and use it to do whatever it is that you need to do with the data, whether it's you're reporting on it, you're doing some analysis on it, you're doing some predictions on it, the tool needs to fit that job for you. Okay, so I would say that in larger organizations, it's typically done through a database because there are limitations to a spreadsheet, whether you're using the Excel version of it or the Apple version of it or the Google version of it. Spreadsheets have limitations. But if you can put things into a database and start applying some of the techniques that you're starting to learn, like normalization, creating these entity relationship diagrams, then you have unlocked a much more powerful way to manage your data. Yeah, you'll be surprised, or maybe not, that a lot of senior leaders that have a lot of the ability to make decisions have very little information to make those decisions on. It's probably the scariest job ever. And so then CEOs or presidents, they then have to rely on two things. Who in their closest circle can give them information, or they have to rely on their gut. And both of those ways have very low probability of actually being close to the truth. So you're absolutely right. If you could be a leader that is very comfortable with knowing where all your data is and you know how to use some database type of approaches, or at least can speak the language to those who are really good at using databases, you'll be able to get to the truth much quicker than just relying on those that are in your closest circle who maybe also don't know either too, or on your own instinct. Yeah. Okay, so hopefully I was successful tonight in describing how databases think better with AI, how they can predict better with AI, and then finally how they can personalize better with AI.